Hello everyone, this is 𝐿𝐸𝐿 𝐸𝐿 and today I am back with another architecture discussion where we will be trying to deep dive into, not trying to, we will be actually diving deep into the architecture of one of the Uber system which is responsible for managing of configurations. So in short, we are trying to design a configuration store and it is mostly useful for some of the use cases like let's say this feature has to be enabled or not, right? So feature flags, you might have heard about feature flags, that we should enable feature flags if you want to ensure your deployment is safe, if you're rolling out any changes. So the architecture or the system name is Flipr. It is based on this blog Flipr making changes quickly and safely at scale. We are trying to make the changes quickly, as in the code changes are pushed out but they are enabled behind any feature flags, right, and safely. There are a lot of practices which are being followed out. We will be trying to discuss those. So let's get started, and we have the notes to help us deep dive into all these details. So let's get started. Now Flipr name itself, I'm not sure about the context of the Flipr, but it might be simple as that you can get yes or no quickly, right? The configurations are simply that, do I have to do this or do I have to not? Okay, as simple. Let's quickly start with the example first, okay, then we will get into more of the details. Why do we need such kind of systems? If you are kind of a new engineer, or if you are just recently joined any organizations, you have not seen, you might have not seen these kind of features or like systems, but this is heavily used in many of the organizations to ensure that any changes which are rolled out to production are rolled out behind a feature flag. It's kind of your A/B testing, right? So multiple organizations follow this, and it's a safe way to do that. We have also discussed this as part of our migration strategies we have discussed till now. So along with traffic shadowing, you try to do this. So again, taking the example first to start with, okay, so let's say this is your feature which you are deploying. Let's say you are deploying some feature in your application code, okay. Now you want to ensure that feature is working as expected. So what you do, you roll out this feature for a shorter cohort of users, shorter set of users, okay. Let's say you start with you yourself. So what you do, you enable this feature for you. So whenever you ask this config that, do I have to use a newer code or an older code, okay, so basically check that if this feature is enabled for me or not, okay. You send particular some of the parameters. In this case, let's say this is a user ID, so you set that send that parameter to this API or a configuration and check if this is enabled for me or not. If it's enabled, then you execute the new code. If not, then you execute the older code. And it helps in the scenarios, let's say if it's not working as expected, okay, if it is not working as expected, then you can roll out the code easily without requiring a deployment. So that is one of the benefit, and then like one of the main motivations of doing this feature flag or maintaining a feature flag system, okay. So let's say you have a CI/CD pipeline, okay, which takes around 20 minutes to deploy the changes. It goes to test environment, then you try to run some tests, and then it is moved to production traffic and all those things, right? So if anything goes wrong, it becomes hard to follow that entire cycle, okay. So instead of that, if something goes wrong, then you can quickly do that without requiring any deployment, without going through that entire CI/CD pipeline, okay. 20 minutes is the, like, one example which I took. If it's larger systems and like if there are a lot of stages in between, it can take lot higher time. So you are saving that there. Now I hope you are clear with the basic idea of it, basic idea of why, like what this system represents and why do we need such kind of systems. Now back to the Flipr architecture, or like what is the idea behind this configuration system. So as we said, right, you basically check around if the feature is enabled for me or not, okay. So this is the basic requirement of our system. So what you do is you basically check on a property key, if it's enabled, if it's, so you generally get a true or false, okay. This is one of the parameter. Or you get like what is the treatment which I have to get. Let's say there are multiple treatments which you can assign to this request. This treatment is concept specific to Amazon. So it's just that based on, let's say for user one, so in here you have just if else statement, right? So let's say this enable feature 1 returns 1. So in case of 1, this is the code which you have to execute. If it is returned as 2, then you have to execute this code. If it's returned as 3, then you execute some other code. So similarly, that different treatments you can assign it, right? So again, the discussion is focused on Uber engineering block, but the similar analogies are followed everywhere in the multiple organizations. So just now I took the example of Amazon, right? So yeah, so the idea is simple. You send a property key to this system. You check what's the response. If it's true, then you do this. If not, then you execute anything else. Now the idea here is, uh, in this case, in this system specifically, okay, the idea is just you get either true or false. Okay, so in case of Amazon, I just mentioned that you can receive multiple treatments. Okay, uh, similar context we are trying to get here. What you are trying to achieve here is, based on some context, uh, this might vary. Okay, so that you can do that incremental rollout. So it don't have to be yes or no, just for on a basis of single configuration. So instead of using a map here, client.get property key, you will use a multi-map. So you will get based on property key and context. Okay, the context can be your complex data structure. Okay, which has, let's say, ctid equal to 1 and user id 1 2 3. So if this is sent, then let's say it's true. If it's ctid 2 and user id is 3, user id is again 1 2 3, then it is returned as false. So the idea is simple. Okay, you are trying to enhance that feature of true and false, to limit to just two variables. Okay, so not receive just true and false, or like just receive two treatments. You get multiple treatments from this, depending on the context which you are setting up. I hope you got the fair idea about it. Now, how it works basically. Okay, how it works. So service is deployed. The idea is that you don't have to redeploy the application. We already discussed that. Why do we need these features? Because we don't want to redeploy our application and again. Okay, uh, what you're trying to do is you call this system, you get the information of this particular uh, what property, and then, or a key, and then you get the answer, and then accordingly you decide if it's a true or false. Either you have to execute the code, or either you have to not execute the code. Now, one thing which I want to mention here is, as I said, right, the deployment of these systems can vary from organization to organization, and not every organization has a separate system which stores these configurations. Okay, so this is a real-time system. What we are trying to do here is, you at a runtime, whenever you get a, let's say, API call for this user and for this city, you check with the system what I have to do. What do I have to enable this feature for this user, or do I have to not enable this feature for this user? Okay, but it could also be possible. It could also be possible that whenever a service is deployed, you retrieve those configurations and then you use those configurations throughout. Okay, so here you are caching the configurations. Okay, so whenever a service is deployed, you cache those configurations in your system and then you use those configurations. Okay, a great idea here, because you are avoiding those frequent API calls back to the server or your separate system which you are maintaining. Okay, in this case you don't have to maintain a separate system. Okay, you just pull out those configurations from some separate github config repository and then cache those configurations and then use those. The problem with that approach is, it works great. The problem with that approach is, it's just that whenever a configuration change is made, you don't have to follow that entire CI/CD pipeline. Okay, but you will have to redeploy the changes so that the cache can be refreshed. Okay, so it's just that you need a cache invalidation strategy if the calls or the configuration calls are not made at runtime. So this you have to make sure, and depending on the stage your system in or your organization is, a call can be taken. Do you need a separate system for maintaining of this, or you can just serve your use case by maintaining a configuration in your GitHub repository? Cool. Now Flipr architecture, how Flipr works at Uber. So this is very much specific to Uber, how it is done. So there are two things. One is you store those configurations. So someone is storing these configurations, and then your service, or like your backend microservices, right? they call to Flipr and ask for like, what is the value of this? Do I have to enable this feature or do I have to not? So this is served via UI. Your engineers or product managers or anyone can enable these features. Okay, once the feature is available, once the feature is saved or like updated on the UI, it is saved to the database via this Flipr backend API. Okay, this is done. Now retrieval of these configurations, the service can also directly talk to the backend API, programmatically reference, okay, to set or update these APIs, okay, or retrieve these APIs. Now one thing is, we here assume that the configurations which are set by a user are only used by a single service, okay, but there is a high possibility that the configurations are used by multiple services, right? So they it don't have to be that a service which has set the configurations is the only service which is pulling out these configurations, okay. There is a high possibility that multiple backend services are using that. Let's say you have maintained multiple cohort of users, okay. One is like internal users, which maintains all the list of internal users. You don't want to define these configurations again and again because it becomes hard. So that is one thing. Let's say then you have made a cohort of, let's say, 80% users, so something of that sort. Okay, so how do you do that? So the idea is very simple. How it's very simple? These clients or these consumer services here, the cursor which you can see, right? These consumer services basically pull out these configurations. Now how it works is, specific to this block, there are two blocks which are there in the Uber engineering blocks directory. This block specifically talks about this consumer service has a client library integrated. This client library is Flipr library only, okay. This library talks with the gateway, okay, and then it pulls out those configurations. There is also a subscription based or a push based approach which is described in another blog, which we might or we might not, but there is a blog which discusses push based approach, that these configurations are saved to the Flipr backend API, and based on the whatever subscription it has, it pushes out those new configurations to the consumer services. So basically consumer services don't have to pull for those config values, and it helps in saving the resources basically. So specific to this block, if we talk about all the components, UI is you manage the config properties, then backend API is used for internal service can talk to Flipr via API. That's great. Gateway is like how other consumers interact with the services. So the idea here is, whatever changes are saved to the Flipr backend, they are pushed out to gateway, and then they are fanned out. Okay, so they are saved to the cache. Okay, they are forwarded to the host agent, which saves these to the own disk. Okay, so you have the data present in cache, you have the data present in the disk, and whenever this consumer service requires this data, it can directly fetch the data from, first it can try from the gateway cache. Okay, if it's not present there, then it can be retrieved from the disk which is here. And client library, as we mentioned, it enables Flipr. So basically, whatever a language a service is written in, it can talk to the APIs. So just RPC, simple RPC, nothing else. Okay, remote procedure call, if you don't know. Just call that API and then evaluate whatever configuration you have depending on the context, and then take a decision in the business logic. Now this is about the architecture of Flipr. If we talk about the features which are offered by Flipr, what are the different features? So the first feature is properties. Property is your key value pair basically, whatever configurations you are storing. So we already discussed that it offers a context which you can store, right? So it provides a lot of flexibility there, what you can define in the context. So you can put in like complex configurations there which can be evaluated in the client library, and the decision can be made. Another thing is operations as in on call, or like operation, how you are managing the operational overload of overall Flipr system. So the first thing is, Flipr has a consistency check module which ensures that data is consistent and it is like very well maintained in the disk, as well as like whatever the data is in the backend or like backend Flipr, the same is consistent with the host agent on disk format basically. Okay, so this is about consistency. There are proper metrics and alerts which should be there. It's, you should not say it's a feature, it's a must have requirement kind of thing. Okay, so that's covered. Now we have to plan for failures. Okay, so and if you talk about scale, right, there are a lot of services which are dependent on this. Their QPS is 3 million, which is very large, right? So 3 million is quite a huge QPS this Flipr is serving. Okay, so what you have to ensure that in case of inconsistencies which arise, you have to ensure that you are in burst case. Basically, burst case cache basically means that you are able to invalidate the case cache, not cache, cache in case of inconsistencies, and then you should be able to update it, basically that. Okay, so you forcing this update on the cache by invalidating whatever previous data it has. If we talk about scale, as we mentioned, it's quite huge scale here. You can see these numbers. Great. Finally is the safety features. So safety features as in whenever you are making the changes on updating the configurations. Okay, whatever configurations you are maintaining there, how you are ensuring the safety, or like there are not any issues arising due to any changes made. So first thing is peer reviews. So human reviews, if there are any integration tests that should run, so all those things which should be there in the architecture whenever the configurations are updated via UI or directly via the backend service. Right. Access control. Now not every user should be able to see all the configurations which are there, so there should be proper access control which is maintained. So who can view, so and who can update these configurations, properties, or context or constants. There are multiple terms, but the main the same, that whatever config you are maintaining, who can view or who can update, basically your CRUD operations, who can do those. So you have to maintain access control mechanism or policies. Rollouts, config rollouts. So configs are roll out incrementally. This is a great feature to have. And again, it's kind of a must have requirement if you are serving this much of traffic, so that the changes are rolled out incrementally ensures that it is not causing any issues in the overall architecture, or it is not impacting the entire customer base of Uber. Great. Uh, one of the great thing is automatic rollback to previous config for problem detection. So the idea, or like the general idea which you average, which you should always follow to ensure reliability of your application is, let's say the changes are deployed to the production. Okay, so your pipeline, or like however you are deploying the changes to the production, you should have it integrated with your automatic metrics and alerts. Okay, so if let's say the system is not working as expected, if the system is not working as expected, the changes should be automatically rolled out to the previous build, which was a stable build. Okay, to ensure that, uh, and this should be done automatically, as in it might happen that it is missed out by a human, or like let's say the alert didn't come to the human, okay, on the device, or like let's say the on call was not available. Bad things happen during bad times, right? So to ensure smoothing, or like smooth rollout of changes, if something goes back, it you should try to do a automatic rollout, so that if it is detected quickly, and then it is rolled back quickly. So this is all about our Flipr architecture which we will be discussing today. We will meet again in new engineering discussions, new architectures. Till then, stay safe. Tata. Bye bye.